Hello everybody, welcome to another Unity game developer video. Back working on that Snake game. I just wanted to make a video showing a system I am working on, a little prototype PvE system where you would be able to destroy enemies. So the way I have it here is I have made a kind of system where if you have enough body segments to fully surround an enemy, it will destroy the enemy. So and this works with varied organic shapes like this. Like I can use this second part of this encapsulation in conjunction with this first circle to also destroy an enemy. So as long as they are surrounded by body segments, it'll destroy them. And it also works for multiple enemies, so I could surround two and it should destroy both of them. Oh, didn't work that time. Still working on a few bugs. They're not really bugs, they're just slight oversights, because in this particular example I have a game object that is being placed at the position of the enemy objects to destroy it, and right now I only have one game object working trying to do that. So if I encapsulate two objects, sometimes it'll work fast enough that it'll be able to destroy the object and then quickly switch to the next one and destroy it, so it looks like it happened instantaneously. But I'm gonna probably create some dynamic system where those objects that are placed at the enemy position will be dynamically instantiated into the world and destroyed after they serve their purpose. So there we go. So I'm gonna actually quickly explain a few things before I jump into the code, and I am going to surround this enemy, and then before I hit my body segment, let's zoom in here. I'm gonna go frame by frame and then show you what's happening. So once it impacts this object, every part of this array up until that point, it is finding the body segment index of the object that was hit, and it is taking running a for loop from the position of the 0th index of that body segment array down to that position. So it's only doing all the body segments up until that point, and then it is every segment in that point is using a two-dimensional a three-dimensional for loop. So it's a for loop within a for loop. So each of these segments of the array are cycling through the segments twice. So this first segment is going to cycle through the entire array, shooting a raycast at almost every single part of the segment. Then the second segment is going to do the same thing, shooting it throughout the entire body segment, third, and so on until it completes the loop. So the reason it doesn't look like there are that many rays being shot out, I mean, it looks like there's a lot of them, but honestly this whole section would be completely white from the amount of arrays being shot if it was shooting to every single part of the array, because it's just like it's just these amount of objects detected for that loop, just like completely compounded, so that many of them like to a factor of itself. So that's a lot of raycasts, and I actually in the code it is detecting through the for loop, and whatever that established integer for the beginning of the for loop, it is finding that object, that number, and it is discriminating with a modulo operation. So instead of every single element, shooting a ray at every single other element, it is doing every 3 or every 5, and I'll show that in the code in a bit. So it is shooting out these rays to try and detect an enemy object. I don't expect enemies to be much smaller than this pillar right here, but if they were, you see they might be missed by the raycasts. I can easily fix that issue by slightly increasing the accuracy by changing the modulo operation to look for a smaller remainder. So right now it's just doing it every, I believe, every 5 body segments it is shooting at every 3 body segments. So I could tweak that number to get a higher accuracy for that. And it is shooting out that raycast, and if it detects an object with the tag enemy, if I go back forward a few more frames, if it detects that object is going to shoot raycasts out in every direction. Right now it's not showing this one for some reason, but it is shooting that raycast. It's just an issue with the debug draw array. So it's shooting it out in every direction. And when it shoots those out in every direction, it is detecting if it hits a body segment. So right here, it is missing the body segment, it's missing it. It's hitting that one for sure. But those, there's an array of bools. If I go into this target object, and I go down here to the surround script, the one that's using these raycasts, I have an 8 element array for each of those directions. So 0 through 7. So element 2, which I believe is this one, is hitting part of the object, and this runs for a full second, I believe. So it would be pretty unreasonable for it to expect it to hit the desired amount of body segments within just 1 frame, because it'll be very unlikely, and you'd have to impact the body segment several times for it to eventually work. So it is running these raycasts for about 1 second, so as the objects are moving past it, if these objects are running past it and it impacts it, it's going to check that that bool that to a true statement in that checks array. So if certain requirements are met with these checks array, which I will show in a bit in the code, the object is destroyed. If not, all the elements in the check array are reset to false after this cooldown meets 0. So if we go forward another frame, you'll see those bools change at the bottom. See, now it found element 7, and now it found element 1, and I believe that was enough of a requirement for it to destroy the object. So the object has been destroyed. So if we go back into the game and surround another one, we can see it work without the frame by frame, and the object is destroyed. So let us go into the code, and if I go down here, this is just a general time management that I have for the objects. Like I was saying, when it reaches that cooldown, if the current time reaches 0, then it runs a loop through those objects and it sets them all to false, just so it doesn't keep those objects as true, those bools in the array set as true, so it'll eventually meet the requirements whether or not it should. So it's resetting those when it doesn't meet the requirements. So this impact point here, that's what I was talking about, where actually if I go down to it's running an on trigger enter. This is the target object. This is the head of the snake, the head of the player. So once it hits one of the body segments, it'll detect it and reference its tag. If its tags as player, it's hit a body segment. It'll run a for loop through the length of those body segments, and if it equals one of those body segments, it'll find the index of it, and it'll set that index as the impact point. Now we're going to use that impact point integer variable up here, and if it's not detecting an object, the impact point is set to -1, and that's just so that everything resets when it's not detecting an object. But when it is detecting an object, that impact point is going to be greater than -1. So it's running a loop through. It's running a loop from the first index of the body segments. It's running a loop from the first index of the impact point in the body segments down to the first element of that body segment array. So if I go into the view of here and I just do a quick turn and I hit it, it is going to show that it is running the loop from this body segment all the way down to the 0th index. So it is doing that, and then is running a second for loop. This is the second for loop that is shooting that array cast from each element of that array to every other element of that array. So without this modulo operation right here, it will be shooting at every single element of the array will be shooting it at every single other element of the array. But with this modulo index, the I segments are the first part of the body segments. So every 5 body segments, it is going to shoot a raycast at every 3 body segments. I believe that's how it works. I'm not sure, but just to make it easier to understand, I'm using that remainder to detect, to calculate how often it should perform these actions. So it is shooting that raycast from the position of that body segment to the desired position of the body segment for the C loop. So we have the I for loop and the C for loop. It is shooting from the I for loop into the position of the C for loop. And then I have this debug section here where it's just drawing the ray so it's easier to visualize. If it hits an object with those raycasts named enemy with the tag enemy, then that S-check object that I will show you right here, if I find that S-check object, where is it? Here it is. If I focus on that object and then I go into the game, and you can see down here in the game view, if I encompass an enemy, it'll move that object directly to where that enemy was, and then it'll run those functions. Moves it there, and if I zoom out, it's easier to see. You can see with reference to where the other objects are when it moves. So it's right here, and then it moves right there. So it's moving that object into that position, and then I'm running a for loop for through this check accuracy integer. This check accuracy integer is determining how many degrees it'll turn every time to shoot the ray to detect the objects around it. So it is pretty much just determining how accurate that is moving. If I have the check accuracy array set to 4, it'll shoot up, right, left, and down. If I have it set to 8, it'll shoot up, left, right, and down, but it'll shoot 1 between each of those as well. And an easier way to explain that, I don't know why I was going out of my way to show you with the reverse perspective of a camera just now, but down here, that S-check object, its rotation is being initialized back to its identity, and then it is rotating the object 360 degrees divided by that check accuracy times what the loop is on. So a better way of saying that is running the loop. Let's say the loop is currently at 0 because it hasn't added anything to it yet. So is running that loop. It is rotating it 360 degrees divided by our check accuracy is 8. So it's shooting 8 rays. Check accuracy is 8, so 360 divided by 8 is 20, I believe. 20 times D. D is 0, so it just shoots a ray perfectly forward. Next time it runs through this loop, it is going to turn it 20 times 1, so it's going to turn 20 degrees and shoot another ray. So let me jump into an infographic I have. So in this graphic, ignore the words for now, but just visualize with me. It is shooting it up at 0 degrees, and then that 20 degrees times 1, it initializes it again, and then shoots at 20 degrees times 1, so here's 20 degrees, and then initializes it again, and 20 degrees times 2, so 40 degrees, initializes it back to 0, 20 degrees times 3, 60 degrees, and it goes all the way around. The explanation is slightly off with the how I'm saying where the degrees are hitting, but the math checks out, so I guess that's all that matters. If we jump back into the script, it'll shoot all those around, and this is fully adjustable because it's doing math by dividing the radius of it by the check accuracy. So if I change the check accuracy, it'll change with it. So it is shooting a raycast every single time it turns, and so it's shooting it in all those directions. And then so there's the debug ray, so it's shooting the green ray, and then it is running a loop through those parts. And if it is hitting either that part, or if the ray is just for some reason too close to the origin within the object and it's hitting the object, it'll check that a part of the array as true. That checks array that I was just showing. And this check time will be set to the cooldown. So that's that cooldown where once it reaches 0, it'll reset all those checks to false. And then is running a separate for loop, again with the based on the check accuracy number. And this part, everything so far is adjustable except for this part. I haven't done the coding to make it run through the loop and check these true or false statements dynamically based on the check accuracy. So right now it's just set with the check accuracy in mind as 8. So is 0, 1, 2, 3, 4, 5, 6, and 7, all the elements of an array with the length of 8. So right now I have it where if the raycasts are being shot out, if the 0, 2, 4, and 6 part of the array is hitting, then it will destroy the object. If the 1, 3, 5, and 7 part of the array is hitting, then it will also destroy the object. And these are just this is just some way to add leniency to the detection of the body segments around it, because if I did have it need to check every single part of that array, chances are it would not detect all of them and it would not destroy the object. So if I go back to the infographic, the red lines indicate the first requirement, and the blue lines indicate the second requirement. So it's the red or the blue. So if all of the red hit 0, 2, 4, and 6, the red lines, then it'll destroy the object. If all the blue ones hit 1, 3, 5, and 7, then it'll destroy the object. So if it's either of those requirements, the object will be destroyed. And here's that separate for loop that's going through the check accuracy loops. the check array. It's taking the check accuracy because that's the length of the check array because it's initialized at start, and it is setting all those as false. That's if it doesn't detect all of them. That's if no, that's after it destroys the object. If the check time gets to 0, then it sets them all as false as well. So this is just initializing the array for the next target. So this all looks pretty cluttered, and I hope it isn't too confusing or just inefficiently done, that you're not getting the explanation that I'm trying to put out there, because if you are struggling to understand what I'm saying about this script, I'm 100% sure it's on me, because I'm sure there's a much simpler way to do this. But actually, let me explain. I didn't explain why I am shooting these rays out and detecting the body segments, because watching the video, you're probably thinking, why would I be shooting out those separate green rays if these white rays right here are just detecting the enemy object? Like, why not just stop here with these white rays that are shot out? Why not just have these white rays destroy the enemy? Well, I want the function, the gameplay mechanic to be, if you completely encircle this object, it'll be destroyed. The problem with that, if I just use these rays, if I made a U shape here, if I just went like this, following my cursor, if I went up, down, and then made a U shape, and then I connect it again, it would still shoot those white lines between it, and it would destroy the object. So this secondary measure is having the object detect if it's really, truly, fully encapsulated by body segments. So it is necessary for that detection, because otherwise it'll just destroy the object anyway. So that is what I've been working on. I hope I didn't do a completely terrible job explaining the new functionality of this script, but I like how it's working so far. If you do not follow me on Twitter, please follow me on Twitter at cyberbully20xxd. That is my developer page where I put my game design stuff. I would like to make more YouTube videos explaining my game design stuff in the future. If you like what you watched, subscribe or go follow me on Twitter. If you had some issues with it, and I'm sure you did because of how I was explaining things, drop a comment. I'll see you in the next video. Thank you.